This presentation concerns the first comprehensive example in Module 8, and it involves the analysis of the decentralized system versus the proposed centralized system for the medical center using a syringe as the um, basis for the example that we'll show. And once we get this thing started, and I'll try to use the same format that's in the modules just to make it clear where the calculations are headed here. So first we had the three departments A, B, and C, and I'm starting here with just the inputs. The main inputs were the weekly demand, and they were labeled as mu1, mu2, and mu3. And I can come up here and I can use Greek letters here, and I can further go here and make the 1, the 2, and the 3 subscripts. Now this may seem like overkill, but I think it's never a bad idea to carefully document what you're doing here, because it will definitely prevent mistakes later. And also, if you're ever in the position to have to show this to anyone, it'll be much clearer, and you'll be able to explain it better. And then we have the values for sigma 1, sigma 2, and sigma 3. And I'm just going to see if I can just do this and then just change the m's to s's, which would be the sigma. Oh, that was cool. Okay, and then the inputs, and I'm going to make these all centered. So the inputs were the weekly demands of 4750 for Department A, for Department B 1500, and for Department C 2250. And I think I'll just make everything a little bit bigger here. Okay, the standard deviations, one of the inputs you may recall were the coefficient of variation for the weekly demand forecast, and the coefficient of variation was 18% per week. So we can just hardwire that in because we're not going to change it. So 0.18 times the weekly demand is the standard deviation. So we see the standard deviations here. One more. Generally don't like to hardwire things, but just for the sake of moving this along, I'm just going to hardwire the things that aren't really going to change in this analysis. Okay, so in order to determine the capacity buffer, we have the 5-step procedure. And the first step in the 5-step procedure is to find the total demand for, and we have to do this for each department, during the, that so-called RLTD period, the period of the review period plus the lead time. And the label for that is I'm just gonna move this and edit this, and oops, and it is, hopefully this works nicely. Oops. Yeah, I'll have to just change the format here. No. Plus, it's T plus L, sorry. All right, I'm gonna have to change this to Calibri and a subscript. All right, that wasn't too painful. So that value is the sum. Remember, the period is a weekly review period and the lead time is 2 weeks. So T plus L is 3. So we want to go up to the demand and multiply by 3. And again, this is another thing that you may not want to hardwire, but we're going to do it that way anyway. And then we have the standard deviations. And here we have to be a little careful because this is something that is going to be different depending on whether or not the demand for each department for the 3 weeks is perfectly correlated across the 3 weeks or independent across the 3 weeks. And in this case, we're assuming that the demand is independent across the 3 weeks, which makes sense for something like this, a medical device. It's not a innovative product, it's a stable product, it's a mature product. So you would think that the demand for week to week, the variation would be independent of the prior week. So we're going to then take this, and it's going to be equal to the square root of sigma 1, the first week sigma squared, plus the second week sigma squared, plus the third week's sigma squared. Now, we could have also done this by taking the square root of 3 times 855. That would have worked, but this works too. And so we get a value here, and I'll just show it with 0 decimal places, and then we'll copy it across. So that's an important calculation. That's the standard deviation during the RLTD period, and because the demand is independent across those 3 weeks, we take the square root of the variances added together. Now we need to have the CV for the period T plus L. So I'll write that in T plus L. And since I'm dealing with all Greek letters here, let's get rid of that. And then let's make this a subscript. All right. And this is a pretty simple calculation, which is the standard deviation divided by the mean value. And again, we will make this 3 decimal places and go there. All right, 0.104. All right, now we have to calculate the f of k, which is equal to 1 minus the service level. We're assuming that the service level for this example is, I believe, 99%. Yes, 0.99. That will not be something we'll change, and we'll divide that by the CV. So that's 0.096. And remember, if we're going to use the table automatically, we have to round this off to 3 decimal places. Okay. And that will be the same really for each one because of the fact that we have the same CV and the same safety stock factor. All right, now we have to find K. And as in one of the early videos, I was not as prepared as I could have been in terms of getting ready for this, so I did not pull in the FFK, the FK table into the spreadsheet. So I'm just going to take a quick break, and then when I come back, the table will have magically appeared. Okay, here we are, and the table has appeared, and now we want to do a lookup. So it's V. And remember, if we want to be good about this, we want to say if the f of k is greater than 0.4, make it equal to 0. Otherwise, make it equal to the VLOOKUP of f of k, comma, and then we want to grab the whole table, not with the headings. Okay, and since we're going to be copying this, we want to actually put some dollar signs in front of the values there for the rows and the columns, and we're in the second column, so that should, like I usually do here, I usually just say yes and hope for the best. And since we matched the number in the notes in the module, it looks like we have the right number. All right, and then finally the safety stock is equal to the value of k times the standard deviation. And again, we'll round that off and do this. And then over here, we can say the total. This is not the way it's done in the notes, but it'll be fine. And so the sum of all the safety stocks is equal to these 3 values, 2451. Now, one of the things you could add to this, and it was done in the notes, but it wasn't done in a table like this, is we have to put in the holding cost. We really need just the total holding cost, but you know, we could actually do it per department. So it's equal to the 0.25, which is the holding rate, the 1.75, it's the product of those two, and the safety stock. Now you might be thinking, why are we using the annual holding rate? It's because the safety stock will be the value of the safety stock throughout the year. So basically every day of the year we'll have, on average, we'll have this much safety stock. So this is the cost for holding it for the year. And this is in dollars. And that's not very pretty looking, so let me just fix that one. I'll make it look like that. It looks a little bit nicer. And I guess not. Anyway, and we'll do this. And then we'll copy this down and we'll make this a dollar value. Okay, so it's the 1072 that we saw in the notes. All right, so that is the analysis for the decentralized system.